What are Earth's magnetic field lines? We know that our Earth is assumed as a magnet that has magnetic fields in it. The magnetic field produces the imaginary line of the force around the field. The magnetic field lines of Earth are imaginary magnetic field lines radiating from the southern half of the Earth and re-entering the Earth at the northern half. The magnetic field of the Earth creates the field lines at the surface of the Earth. The Earth's outer core contains molten iron and nickel. The mixture of these molten iron and nickel produces an electric current. This is due to the mixture tends to generate heat that tries to escape from the core, creating the current called convection current. The motion of the convectional current of the Earth thus creates the magnetic field at the outer core. This magnetic field consists of imaginary lines that emerge out of the core and travel in space, re-enter the Earth's core, called magnetic field lines of the Earth. Properties of magnetic field lines of Earth. The magnetic field lines of Earth never intersect one another while traveling between two poles of the Earth. The magnetic field lines of Earth can trap the charged particles, thus, the Earth's magnetosphere is formed. Unlike bar magnets, the magnetic field lines of Earth are asymmetric with respect to the magnetic axis. The magnetic field lines of Earth create the loop at the center of the Earth. Magnetic field lines of Earth direction. Since the Earth's magnetic field is due to convection current, the direction of the magnetic field lines of the Earth depends on the direction of the conventional current. The motion of the convection current is always vertically upwards. The magnetic field lines of the Earth are associated with the orientation of the poles, not on geographical direction. Thus, the magnetic field lines of Earth are in an upward direction. The field lines enter the South Pole from the core and leave at the North Pole. The direction of the magnetic field lines of the Earth is reverse of the regular bar magnet field lines, as in bar magnets, the field lines always travel from north to south. This is because the geographical North Pole is actually the South Pole of the Earth, and the geographical South Pole is the North Pole of the Earth. The reason behind this is the regular magnetic property. Since we regard the Earth as a large magnet, the bar magnets are influenced by the Earth's magnetic field. The Earth's South Pole attracts the north of regular bar magnets and vice versa. Thus the magnetic field lines of the Earth's direction are reverse of the available magnets. The magnetic field lines intersect at the surface of the Earth. The angle of inclination of magnetic field lines ranges from 0.90. In the equator, the angle of inclination of the magnetic field lines is 0. In the North Pole, the inclination is +90, which is a vertically downward direction, and in the southern hemisphere, it is -90, which is a vertically upward direction. The angle of inclination of the magnetic field lines of the Earth varies with the latitude. Where is the Earth's magnetic field lines at its strongest? The location at which the magnetic field lines of the Earth will be strong is based on the density of the magnetic field lines. Generally, the density of the magnetic field at any point corresponds to the magnetic field at that point. At both poles of the Earth, i.e., the North and South Poles, the force of magnetic fields is strong. The field strength begins to minimize as the fields are far apart from the poles and near the equator. Thus at the poles of the Earth, the density of magnetic field lines of the Earth is more, and hence it is at its strongest. The reason behind the strongest magnetic field lines at the poles is that magnetic flux. The magnetic flux specifies how tightly the magnetic field lines are packed together. The flux spreads out in space from the Earth's surface. Thus, we receive maximum field lines entering and leaving the Earth's core at the poles. Hence magnetic field lines of the Earth are at their strongest at the poles. Frequently asked questions. Why does the Earth have magnetic field lines? Our Earth contains lots of minerals in its core. Among them, iron and nickel are empowered to the magnetic field lines of the Earth. The solidification of liquid iron and nickel in the Earth's core is responsible for the magnetic field of the Earth. When the iron and nickel core is cooled and crystallized, it rotates around the liquid core, generating the electric current called a convectional current. This convectional current generates the magnetic field that emerges from the Earth's core out of space. The imaginary line of force emerging magnetic field of the Earth is called magnetic field lines of the Earth. What happens if the Earth loses its magnetic field? Earth's magnetic field acts as a shield to our planet. If the Earth's magnetic field is lost, there will be no magnetosphere. Without a magnetic field, our Earth would strike by more cosmic rays and solar radiation, which could cause severe effects on the living beings of the Earth. There will be malfunctioning of the power grids, which will damage the satellite communication system. The depletion of the ozone layer increases and thus increases the aurora activity on the Earth. The charged particles from the Earth can easily enter the Earth and hence collides with the upper atmosphere, which causes ionization of particle to give carbon-14 isotopes and thus increase the cancer rate. Losing the magnetic field causes the ending of life on the Earth. What are the advantages of magnetic field lines of the Earth? The magnetic field lines are responsible for most of the habitat on the Earth. There are numerous advantages of the Earth's magnetic field lines, a few of them are listed below. Earth's magnetic field lines create the magnetosphere for the Earth. Using the direction of the field lines may birds, insects and animals navigate. The magnetosphere protects the Earth from harmful radiations such as solar radiation, solar wind, and cosmic rays. The magnetic field protects the ozone layer from being depleted by the chlorinated radicals from space. The magnetic field deflects the most charged particles from space entering the Earth. Magnetic field lines of the Earth are one of the reasons for having the Moon revolving around the Earth. Does the magnetic field of the Earth affect humans? Not really, the Earth's magnetic field does not affect humans directly. Sometimes the magnetic storms affect us. Magnetic fields are essential to living on the Earth. There will be the minute effect of the magnetic fields of the Earth. This effect is experienced by high-altitude pilots and astronauts. They experience the variation of magnetic field causing the magnetic storm and hazard the radiation. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.